right, subscribers, I know you don't remember the goal of 13.1, but just to refresh your brain, it's to use trigonometric identities to find trigonometric values and to simplify expressions. A trigonometric identity is an equation involving trigonometric functions that is true for all values for which every expression the equation is defined.
First step is to draw a graph. Refer to the trig identity sheet to solve the first problem. Then figure out what quadrant the angle is in. The third quadrant is between 180 and 270 degrees, which is where this problem is. We're trying to find theta, and the theta angle is always closest to 0, 0. Secant is hypotenuse over adjacent, so secant theta equals -2, so 2 over 1. But the hypotenuse can't be negative. Make sure to pay attention to the positive and negative values based off of the quadrant that you're working in. The other value is -√3 because it is a 1, 2, 3 triangle. Tangent is opposite over adjacent, so -√3 over -1. And this simplifies to √3.
First, you are going to refer back to your trig identity sheet. When you start your problem, you are going to try and convert whatever you can into sine and cosine. Since sine is already in its sine form, we are going to convert secant into 1 over sine. This turns our problem into sine theta times 1 over sine theta minus sine theta. Then we multiply that, and it turns into sine theta over sine theta minus sine squared theta. Sine theta over sine theta equals 1. So it turns into 1 minus sine squared theta, which can become 1 minus cosine squared theta. Cross out the ones, and we are left with cosine squared theta. Thank you.
For 13.2, you will see 3 different types of problems. The first step to solve these types of problems is to simplify one side of the equation until the 2 sides of the equation are the same. It is often easier to work with the more complicated side of the equation, believe it or not. The second step for these types of problems is to transform the expression into the form of the simpler side. Right, so Riley's looking at her trig identity sheet and trying to get all sines and cosines. So she's turning cosecant theta into 1 over sine theta. Cosine theta, she's keeping the same but putting a 1 under it. And she's turning tangent theta into sine over cosine theta. Now she's going to cross out her sines, and then she's going to cross out her cosines, and she will be left with 1 equals 1. And that's your answer, folks. Yay. Alright, famgoons, so don't be alarmed when you see the squares. It's the same thing, and it's given to you on your trig identity sheet. Riley's turning cosecant squared into 1 over sine squared because you want the cosines and sines. Tan squared theta to sine squared theta over cosine squared theta. And she's turning cosine squared theta into cosine squared theta over 1, keeping it the same. Now she's crossing out her cosines, she's crossing out her sines, and she gets 1 equals 1 again. Good job, subscribers.
The first thing you're going to do is split 1 plus cotangent theta over cosine theta into 2 equations. This will give you 1 over cosine theta plus cotangent theta over cosine theta. Then you will look at your formula sheet and write 1 over cosine theta as secant theta. Now you will be changing cotangent theta to cosine theta over sine theta, which you will then put all over cosine theta over 1. Now you will write your new 2 equations as multiplication rather than division. When you flip it, the problem will now be secant theta plus cosine theta over sine theta multiplied by 1 over cosine theta. You will then cross out the cosine thetas. You are now left with secant theta plus 1 over sine theta, which can be converted to cosecant theta from your formula sheet. And you are left with your final answer. Secant theta plus cosecant theta equals secant theta plus cosecant theta.
This concludes our video, but stay tuned for some bloopers if you're a real subscriber. Also, turn on our post notifications if you want to be entered in a giveaway because we're giving out a free TI-89 for the lovers of math.
It's every day, bro, with the Disney Channel flow.
Izzy, that's a frick. Okay, no, Izzy, film this.
Okay, you guys, that was good. No giggling, it's not funny. Riley, all of you that wanted to know what Macy and Molly's child would look like.
It's so terrifying. Oh my god.
Alright, let's vote who has the best shoe game here.